All right, guys. So, three things that you're going to be able to accomplish for today. First, you're going to determine if a relation represents an inverse variation. You're going to find related values using inverse variation. And you're going to use inverse variations to solve real world problems. So, first off, what is an inverse variation? So, if the product of two corresponding values of two quantities is constant, okay, meaning the same, then one quantity varies inversely with the other. When we do that, we end up with equations that look like this, okay, where k equals x times y, or y equals k divided by x. These two are the same. Now, what is the k? We know what x and y are. K is what we call the constant of variation. The constant of variation. All right, so what we're going to do first is in example one, we're going to determine if the table of values represent an inverse variation. If so, we're going to write an equation to represent the inverse variation. So we're going to write one like looks like this. So how do we know? So it says first, if the product means to multiply. So here I'm going to find 2 times 12 is 24. Here, 3 times 8 is 24. 4 times 6 is 24. And 6 times 4 is 24. Because these are all the same, oh, sorry, I put the wrong definition. It represents an indirect variation. Sorry, guys, I messed that up. This should not say inverse. An indirect. I don't know what I was thinking. Indirect. Okay, those should both say indirect variations. That was a major typo on my part. Okay, now as long as those are the same, we have what we call an indirect variation. So how do we write our equations right here? Okay, so we're going to write our equations in basically all we're going to do is we're going to write it in this form. But all we need to know now is that number, the x times y, that is going to be our k. Okay, that number that with the product, that is the constant of variation. So our equation is simply just going to look like, and we're going to write it like this. We're going to say y equals 24 divided by x. Okay. All right, let's look at b. So we're going to multiply. So 3 times 6 is 18. 4 times 8 is 32. Already, we can see these are not the same. Okay, so this is not an indirect variation. Okay, so sorry, we can use inverse and indirect kind of the same. So you're going to see both of those written. So I apologize. I got a little carried away there. Right. So example number 2, this says it wants us to finding values using inverse variation. So example A says if x varies inversely with y when x equals 2 and y equals 5, what is y when x equals 12? Okay, so this right here tells us that we can write one of these equations. Okay, that just means it is an inverse variation or it is an indirect variation. So what we want to do is we want to try to find k. So k, we multiply the 2 and the 5, which is 10. Okay, so k equals 10. Now our equation, just like we did right here, I'm going to say y equals k, right, which is 10 over x. So the next part of the question says, what is y when x is 12? Right? So we're going to say y equals 10 divided by 12. Okay, and if you want to get a decimal, we can put it in 10 divided by 12, 0.83. We don't have to repeat the threes. All right, sorry, example 3, that there was a little, so this is just going to go to that next page, right? So we'll just kind of work around that. So I need to fix that. All right, so this one says if P and Q vary inversely. That just means that this is true, that we can write an equation. Okay? So P is 29 and Q is 16. So now we're not dealing with X and Y, but we're still going to work with K. K this time is just going to be equal to P times Q, right? Which P is 29, Q is 16. So K equals 464. Okay. Now my equation, I'm going to say y equals k divided by x. So y equals 464 divided by x. Right? And we're, oh, sorry, not x. It says, notice how the first one says if x varies inversely with y. If p and q vary inversely, so that p, that first one, that value, that's going to go down below, right? If p and q vary inversely. So my equation right here, instead of x and y, we're going to have q and p. So if we're trying to find q when p is equal to 116, take 464 and divide it by 116. And we get 4. Okay. So first thing that you're going to do is multiply your two values. Okay. Then you're going to set up your equation with x and y or p and q. And then you're going to substitute that other number in to find your answer. Okay. All right. I'll go ahead and flip over to the back. And we're going to look at some application problems, some real world types of problems, right, of inverse variation or indirect variation. So this question says, on a car trip, okay, so you're traveling, right, the time of the trip varies inversely with the speed traveled. Okay, so what we're going to do is the time of the trip. I'm going to let that be t, varies inversely with the speed. That's going to be s. One car drove 48 miles per hour and it took them 50 minutes. Okay, so one car drove 48 miles per hour. This is speed, and it took them 50 minutes. This is time. If a different car made the same trip at a speed of 80 miles per hour, how many minutes would the trip take? So, first, we are going to find our constant of variation by multiplying s and t. All right, so here my s is 48, my t is 50. So my k equals 2,400. Okay, so here it says the trip varies inversely with the speed. So my equation, we're going to say the speed is equal to the constant of variation divided by t. Okay, so now the question wants us to find right, so our equation says the speed is equal to k over t. Now, make sure that we substitute these correctly because it gives us 80 miles per hour, and we are trying to figure out how many minutes, the time, right? So what we have here is actually 80 for the S. Our K is 2,400 over T, okay? So here, how do we solve that? Essentially, the easiest way to do this is when we solve, these are going to switch. So T is equal to 2,400 divided by 80, which equals 30 minutes. So think about that. All right, when it talks about inverse variation, the faster you drive, the less time it takes you to get there. So they're driving 48 miles per hour and it takes them 50 minutes. If another car drives 80 miles per hour, it's going to take them fewer minutes, right? And so that makes sense. Okay, so let's look at the next one. So it says, when building a house, the number of days required to build is inversely proportional, okay, to the number of workers. Okay, so what that means is the more workers you have, the less time it takes to build the house. So, so we're going to say the number of days, D, and the number of workers is W. Okay, so our equation, right, is because the number of days required to build is inversely proportional. Okay, my W is going to equal K over D. All right, the one that is D is inversely proportional. That goes in the bottom. All right, so now we have to try to find K. Okay, and so remember K is equal to W times D. So one house was built in 31 days by 32 workers. Okay. So our constant of variation, we have 31 workers that build a house in 32 days. Right? So the constant of variation is 992. The question wants us to figure out how many days would it take to build a similar house with 8 workers. Well, if you only have 8 workers, it's going to take a lot more days. Okay, so let's figure out how many. So we have 8 workers. So 8 equals 992, that's the K, divided by D. Okay, so D is going to equal 992 divided by 8. Because 992 divided by 8. It's going to take 124 days. All right, we have one more problem. The time it takes an ice cube to melt varies inversely with the temperature. Okay, so here we've got time and temperature. So I'm going to let X be time and temperature be Y. Okay, so we know that the temperature is equal to the constant of variation divided by X. All right, the time varies inversely, so that X goes in the bottom, K goes on top, Y goes right here. If it takes 2 hours for a 5-pound block of ice to melt in a 60-degree room, okay, so this right here is our time, and 60 degrees is our Y. This number is irrelevant. You don't need it, okay? So our constant of variation is going to equal X times Y, which equals 2 times 60, which equals 120. So our equation is Y equals 120 over X. We want to know how long would it take for a 5-pound block of ice to melt in an 80-degree room. Okay. Remember, Y is temperature. So we're going to say 80 equals 120 divided by X. X equals 120 divided by 80. And it would take 1.5 hours. Right? That makes sense because it took 2 hours in a 60-degree room. So in an 80-degree room, it'll take less time. Okay? All right, so you guys can go ahead and get started on your assignment.